Okay, so we were doing volume studies. We have covered the topic of intersection counts and arrival and departure. Then we moved on to network studies. Network studies, we are doing two. The So we will do two types of network studies: the limited network and the other one would be uh, the statewide program. So right now we are doing limited network, which is the network around a facility, and we are trying to see what will be the impact of that facility on the road network. Okay, so you select a small part of the network and then you just do the study on them. And in those studies, we have two types of counts: the coverage and the control. The control is for the full required time period, and the coverage is a part of the required time period. So we have this network, okay, which has 7 locations. You can see 1 to 6. I have numbers, and I have location A. Location A is my control. Okay, we need data from 12 noon to 8 p.m. at night, so total 8 hours on any particular weekday. On, you can see, a weekday. So I just need 1 day 8 hours of data. There are only two field crews or two teams available. So one of them has to be on A, the other one will rotate from one location to the other. So since I only have one other team, so all other locations have to be done one by one. So 8 hours on location A, and the remaining, in the same 8 hours, I have to finish the other 6 locations. So if I spend like 1 hour on each location, I'll finish in 6 hours, which is within the 8 hour time period. But if I spend like 2 hours or 1.5 hours, I cannot finish 6 locations in 8 hours. So more than 1 hour will not be possible here. Okay, so this is what is done. So you can see for location A, I have the 8 hours of data. For the remaining locations, each location has 1 hour of data, and this is the count of 1 hour. So first of all, I will start with calculating the total of location. So the total 8 hour count at location A is 7067. Okay. Now for the other locations, I have to convert the daily count into the 8 hour count. So for that I will calculate factors which are called as expansion factors. Okay, so I will go there. Let me change it a little bit. Okay, so I will, for each hour, I will calculate expansion factor. So I have hours from 12 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, and 7 to 8. Okay, now how do we calculate the expansion factor? You take the count of that hour. So I'm calculating for 12 to 1, right? Count for 12 to 1 is 8 to 5. So 8 to 5 divided by the total, 7067. Okay, this is 0.11. Okay, so for the second one, it will be 811 divided by the total. So it's 0.12, 0.13, 4, 5, 13, 0.0. Give me 1 second. Zero 0.06. Okay, these are the expansion factors. Now how to use the expansion factor to calculate the count? I will add some columns here. So I have location, and I want to calculate location 1, 2, 3, 4, 5, and 6. and for each location I need to calculate the 8-hour count. Okay, don't need this here. Okay, so location 1, the data is taken between 12 to 1. Okay, how much is data? 840. Now the rule is that whatever happens on location A, the control count, the same trend should happen on the other locations. So you see on the control location, the amount of data we have between 12 to 1 is 11%. Okay, so for the other locations should be 11% as well. Okay, just let me check this quickly. Okay, okay, everything is cool now. Okay, so what I was saying is that 840 should be 12% of the total, because it was between 12 to 1, and 12 to 1 is the 12% of the total according to this expansion factor. Okay, so now I will divide to get the total. So it's 7,000. Okay, similarly for the second location it's 625, divide by how much is in this hour? 11%, so 0.11. Five, 6, 8, 2. Okay, similarly it will be done for the other locations as well. You can see there's a gap here because 3 to 4 no data is taken, and again at the end there's a gap because no data is taken between 7 to 8 as well. Yes, and it's completely fine. There's no problem in missing something on the coverage locations. Okay, so repeating the same process, these are the total counts I have. Now I will go to the next step, which is to calculate the peak hour count. Okay, the peak hour, first of all I will look at the data which is given, which is for the control location, and you can see the highest count is for 5 to 6. So this is my peak hour. For the control location I know the time, and this is the volume of the peak hour. Now for the other locations we said you should have the same trend. So the other locations, the peak hour should also be between 5 to 6 for all other locations. Now keep one thing in mind, each of these counts is for a different location. So you cannot compare between them. You cannot compare 1440 with 1215 and so on and so forth and say this is the peak one. No, this is not the peak one because there is no comparison. It's only for 1 hour. Okay, you cannot compare location 6 with location 5. So you can only do it here, and from here I know peak hour is between 5 to 6, and this is the value of peak hour volume for location A. If I go to the other locations, I see that between 5 to 6 there is another count which is for location 5. So for location 5 it becomes the peak hour volume because it's actually in the peak hour. The same rule, applying the same rule which I told you earlier, that whatever trend is happening on the control should happen on the coverage as well. So if the peak hour of control is between 5 to 6, the peak hour on coverage should also be between 5 to 6. So 2 locations out of 7 are done. Location A 1153, 5 to 6, and location 5, 5 to 6, and the count is 1215. Now for the other locations I will do the reverse of what I have done here. Here I had hourly, right? And I was calculating total. Now I have total. For every location I have the total. I want a specific hourly volume. Which is specific hourly volume? The volume between 5 to 6. So I'll take the total. Now I'll multiply. Here I was dividing, so I will multiply now. Multiply with what? Multiply with the expansion factor of the peak hour. It cannot change. I will multiply with the expansion factor of the peak hour. Okay, because this is the hour which has the peak volume according to control location. So all of them will be multiplied by 0.16. Okay, so this one will be multiplied by same number or same factor. Okay, so the first one will be 1120, and the second one will be 909. Okay, so the same would be repeated for all the other locations as well. Okay, moving on, we have another variation of the same study. Instead of taking volumes in different hours, the volume is taken on 8 hours every day, full 8 hours. Okay, and for control locations it is taken on 6 days. Okay, so now we can calculate an average for the control location, okay, for the 6 days. Okay, and then that means we also need to calculate average for the other locations as well, the average of 6 days for the other location as well. Okay, so first of all, let us calculate the average for the control locations. So we already have these numbers. Okay, average location A, so this is 7350. Okay, now for the other locations to calculate average, I need another factor which is called as adjustment factor. Okay, so I make a table here. Adjustment factor will be for each day because each day has a value. Okay, but keep in mind each value is 8 hours, so there is no expansion factor here. Everything is 8 hours now. Okay, so the day, okay, and the adjustment factor. So Monday, Tuesday, Wednesday, Thursday, Friday, second Monday. So this one is the first. Okay, the adjustment factor is you take the the average divided by the value of that day. So 7,000. $1.05, and the same should be done for the other days as well. Okay, these are the adjustment factors. Now let us see how to apply them. I will add another column here or 2 more columns. Okay, I'll put location here, location 1, 2, 3, 4, 5, and 6. Okay, here I will put the average 8-hour count after calculating it. So I have an 8-hour count which is taken on Monday, the Monday 1. I'll take that count and multiply with the adjustment factor of Monday 1, which is 1.05. Okay, so 6825. Okay, for the second one it will be the count of Tuesday, it's taken on Tuesday, 6200, and I will multiply with the factor of Tuesday, which is 0.95. 5890. Okay, so same thing we repeated for the other 4 locations. Each time the count from that location and the factor from the day, you have to match the day. Okay, again it's the same study, but now they are doing it in 3 days. Okay, so for every day, and they have divided the day into 2 different time periods, 12 to 4 and 4 to 8. Remember, we need a total count of 12 to 8. So this 12 to 8 is divided into 2 parts now, 12 to 4 and 4 to 8. Okay, so you can see here, this table shows the control count, the location A. Each day you see two parts here and the total of that day. Okay, Monday total, Tuesday total, Wednesday total, and for each day, for each part, they have calculated the percentages. Okay, these percentages are what? Expansion factors. So expansion factors are already there. Okay, So since there are 3 days, I needed to do certain calculations. So whenever we start with these problems, you see what we can do with the control location. So from the control location, you can calculate the total for the day which you did. You can, because the count is divided for one day, you can calculate the percentages as well, the expansion factors, which is already done. Okay. Now you can, since there are 3 days of values, you can calculate an average as well. Okay, so let me calculate the average for location A. So average location A is 6967. Okay, so this is for the 3 days, the average of the 3 days. Okay, now from the average we can calculate the adjustment factors. A table here. I have the day and the adjustment factor. I put it over here. I have Monday, Tuesday, and Wednesday. Okay, now Monday factor will be like we did last time, 6967, the average divided by the total of the Monday, which is this value. So this is 0.99, and this one is 0.93, and this one is 1. 0.9. Okay, the expansion factors are done. I will take it from here to the next slide because I have the other counts here. Okay, so now you see the counts on the other locations. Okay, now on the other locations you see the count is taken 4 hours at each location. So first thing I need to do is convert these 4 hours to 8 hours. Okay, so I will go there, I'll make a new table and see if I can fit it here. Okay, not possible, but we'll do one by one. Okay, location, 8-hour count, and then I'll add another one for the average 8-hour count. Okay, so for example, if I'm doing location 1, the 8-hour count will be, I will take from here 2213. Now this count is taken on Monday 12 to 4, so I need the expansion factor of Monday 12 to 4. So I go there, Monday 12 to 4, the expansion factor 42.9 means 0.429. Five, 1, 5, 8 or 9. Okay, now to convert it to average, I'll multiply with the adjustment factor of Monday because this count is on Monday. Okay, the adjustment factor of Monday is 0.99. So multiply by 5159. 5107. Okay, if I'm doing it for location 2, I'll do one more. Okay, so the count is taken on Monday 4 to 8. Okay, for Monday 4 to 8, the count is 3000, and the percentage for this from the control count is 57.1, meaning 0.571. So this comes out to be 0.254. Okay, and to convert it to average, I'll multiply with the factor of Monday. It's the same factor because it's the same day. 5201. Okay, now for Tuesday the factor will change obviously, and so on and so forth. So each time you have to match the count of the hour to find out the expansion factor, and then you have to multiply and match the count of the day to multiply with the adjustment factor and find out the average. Okay, and then you can complete the rest here.